before? Well, we'll take this direction as positive, so the momentum before is just the mass times the velocity before, which gives us a momentum of 1.35 kilograms meters per second. Now, the momentum afterwards. This is where, again, we have to remember about vectors and direction. So this time, the momentum afterwards is just mv, but the velocity afterwards is negative because it's coming back in the opposite direction. So when we put the figures in, the momentum is minus 1.35 kilograms meters per second. So we have to remember when we're working out momentum, the distance, direction is important. Have a look at this astronaut. What will happen to the astronaut when he's floating in space when he turns the thruster on his backpack? Well, obviously, the thruster gases fire backwards and the astronaut goes forwards. That's how astronauts move around in space. And what has happened there is that the rocket, the thruster, has momentum in one direction, and because of that, the astronaut has momentum in the other direction. There's a conservation of momentum. When we have two or more objects interacting, the astronaut and the rocket booster, their total momentum remains constant, provided no external forces act upon them. So in the case of the astronaut, he starts from rest. So when the gases going backwards gain momentum, he gains an equal but opposite amount of momentum in the other direction. So we can say that total momentum before the interaction is equal to the total momentum after the interaction. Now, let's have a look at that in terms of collisions, which physics questions often are about. Here we have two cars, a green car and a blue car. Have a look at the question and see if you can work out the answer.